In this quick tutorial, I'll show you how to find the domain of a function. This is part 3 of the series. As discussed in part 1 and part 2, the domain is the set of all values that the independent variable, our x variable, can take on. In question number 1, they're asking us to find the domain of f of x is equal to this function. Now, if you ever run into a situation like this, what you have to do is consider each of these terms as their own. So this will be considered term 1, term 2, and term 3. And subsequently, we're going to find the restrictions for each. So let's start off with number 1. In number 1, we know that this radicand, this part right here, cannot be less than 0. So let's set x minus 2, the radicand, must be greater or equal to 0. And we're going to solve for x. We end up with x must be greater or equal to 2. For the second term, we'll do the same thing. 20 minus x must be greater or equal to 0. And if we solve for x here, we end up with 20 must be greater or equal to x. Or in other words, x must be less than 20. And 3, we're going to do the same thing. Negative 2 bracket x minus 16 must be greater or equal to 0. We're going to solve for x here. And to do that, we're going to need to expand this first. So we end up with negative 2x positive 32 must be greater or equal to 0. And if we solve for x, we bring this over. And if we divide both sides by negative 2, what happens is, recall that if you divide by a negative during an inequality, dividing by a negative causes this to change the opposite direction. So we have x, instead of being this way, x is less than or equal to positive 16. It's very important to keep that in mind for question number 2 as well. So what we're going to do next is a technique that we used in part 2, and the technique was to use a number line. So we're going to start off our number line at 0, and let's make it all the way to 30, going up by 5s. Now, we know that x must be greater than 2 for this first term. So what we're going to do is start off at 2, and we know that it has to be greater than 2. In this restriction, we know x must be less than 20, or equal to 20 for that matter. So we're going to start right here, and we know that it has to be less than 20 until it reaches this 2. And lastly, we know x must be less than 16 according to this restriction, less than or equal to 16. Let's take a look at what these lines cover. From here to here, from here to here, and from here to here. So therefore, our domain for this function is between 2 and 16. How do we write that in a formal way? Here's how. Domain, and you introduce these curly brackets, x such that x is between 2 and 16 for all real values of x. And that's it. So let's do a question that's similar to this in question 2. Once again, we're going to segment this function into 3 parts. We're going to start off with the restrictions for the first term. X minus 4 must be greater or equal to 0. Bringing this over gives us x must be greater or equal to 4. That's for part 1. Part 2, 9 minus x must be greater or equal to 0. Bring this 9 over, and you end up with negative 9 on the right side. Dividing both sides by a negative, remember, we'll change the inequality to x must be less than or equal to 9. Notice that this inequality flipped because we divided both sides by negative 1. And finally, negative 3 bracket x minus 7 must be greater or equal to 0. I'm going to multiply this inside. Negative 3x, positive 21. We're going to bring this 21 over, makes it negative 21. Divide both sides by a negative, changes the inequality to 7. So x must be less than or equal to 7. We're going to create a number line now from 0 all the way to, let's say, 10. X must be greater than 4. X must be less than or equal to 9. stops right there. And x must be less than or equal to 7. This is where they are in common, and so therefore our domain must be between 4 and 7. And the way we write down this in a formal way is the following: x such that x must be between 4 and 7 for all real values of x. So there you have it. Two final examples pertaining to how to find the domain of a complicated function. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.